Welcome to 41st lecture. Today we will solve a problem related to average or active power. We have been studying average or active power for the last 1 or 2 lectures, and for this circuit we will show that the sum of power produced in the circuit is equal to the sum of power absorbed. Right, we are given this circuit where we have this as a ground node, and we'll analyze this circuit. In order to verify this expression, we have to find out power dissipated or absorbed and generated in each and every source and the component, the passive component, right? So it seems that a current is gonna enter from here and is divided in 3 parts. So I1 current enters at this point and is divided in these 2 parts. In order to find out the voltage drop across this 2 ohms resistor, we know that the same voltage, the same node, this and this and this, they are the same node. So 12 at an angle of 30 appears here. So across 2 ohms resistor we have the same input 12 at an angle of 30 volts. So in our earlier lecture we have also studied that the voltage times current divided by 2 times cos of theta V minus theta I is the active or average power in watts. So to find out the power absorbed in 2 ohms resistor, we'll write 1 by 2 Vm, where V, the magnitude of V across this 2 ohm resistor is 12, times the current flowing. The current would be, but before we find this power we have to find current I2, otherwise the expression would be a bit complex. So to find this power out, this is the voltage divided by 2. So this is 6 at an angle of 30 amperes, and power absorbed in this 2 ohm resistor would be 1 by 2. The magnitude of the voltage is 12, the magnitude of the current 6, cos of the difference of the angle, which is cos of 0. This means this is 1. So it comes out to be 36 watt. So power absorbed in 2 ohm resistor is 36 watt. Next we have to compute power absorbed in J1 ohm inductor having inductive reactance J1 ohms. So to find that, we first have to compute the current flowing through it, I3, which is V minus 6 at an angle of 0 divided by J1, assuming current is moving in this direction. Its voltage is V, and this V is 12 at an angle of 30. If you solve it, and you can solve it because now you have gone through many problems with where you convert between polar and rectangular forms, it comes out to be 7.44 at an angle of minus 36 degrees. So with this I3, we can compute the voltage drop across J2 ohm, across the inductor with J1 ohm inductive reactance. That is, the voltage drop here minus the voltage drop here is the voltage drop across, the voltage here minus the voltage here is the voltage drop across this J1 ohm inductor. That is, V across this inductor is the current flowing through it times J2, it's not J2, J1. So I3 comes from here, 7.44 at an angle of minus 36 degrees times J1. J1 is 1 at an angle of 90. J1 can be written as 1 at an angle of 90 degrees. So the power in J1 ohm is 1 by 2 times the magnitude of its voltage, 7.44. So if we solve it, it comes out to be 7.44 at an angle of 90 minus 36. This is 54 degrees. 1 by 2, 7.44 times the magnitude of current, 7.44, cos of the angle between voltage. The angle between voltage and current, 54, is the angle of the voltage, minus 36. So this 54 plus 36, 90. Cos of 90 is a 0. So the power in our earlier lectures we have studied that power absorbed or dissipated in inductors and capacitors is 0 watt, and we will study another power that we call reactive power, which is non-zero in inductors and capacitors. Finally, as the second last step is to find the power absorbed in this 6 ohm, in this 6 at an angle of 0 volts voltage source. 1 by 2, its voltage Vm, the magnitude of the current through it 7.44, cos of the angle 0 minus the magnitude of the current is, the angle of the current is minus 36. So solving this gives us a power dissipation of 18 watts. So power dissipated in this source is 18 watt, and the last step is to find the power generated or produced by the only source, this 12 at an angle of 30. So the power produced by 12 at an angle of 30 source is the current flowing through it, because first we have to find current through it, I1, which is the sum of the two currents according to Kirchhoff's current law. This is 6 at an angle of 30 plus I3 is 7.44 at an angle of. We have just computed these two currents. If we add, first we'll have to convert these numbers into rectangular form, which is left as a homework. For students, it comes out to be 11.29 at an angle of minus 7.1 degrees. And now we are ready to find the power dissipated the power produced by this source, which is 1 by 2 times the magnitude 12 times the magnitude of current 11.29 cos of the magnitude of angle, the angle of the voltage 30 minus 7.1. So it comes out to be 54 watt. So the power produced is 54 watts. So now we are going to make a summary of what? Summary of power produced. We have this power produced, sum of power produced. The power produced is here, and this is the only component where power is being produced. It is 54 watts, and the sum of power absorbed is power absorbed in 2 ohm resistor plus power absorbed in inductor having inductive reactance J1 ohm plus the power absorbed in the source having magnitude 6 and an angle of 0. So power absorbed in 2 ohms resistor, we computed it was 36 watts. The power absorbed in J1 ohm inductive reactance is 0, and the power absorbed in this source is 18 watts. So 54 watts. So the answer, we have finally verified that for this circuit, sum of power produced is the same as the sum of power absorbed, and it will be true for all AC circuits. We'll keep on studying AC power in our upcoming lectures. Thank you.